So, back to good old geometry here with special rights. So, couple of reminders if it's been a while. I always like to start generic, get specific when it comes to this. So, I mean, simple stuff like the hypotenuse is always the longest side. It's always across from your right angle in a right triangle. The other two are legs. In a 45, 45, 90, they're the same. So if we're talking generically, your two legs are just x, and your hypotenuse is going to be x times the square root of 2. Now, knowing this pattern is important because when we get down below and I start giving you this side or this side, we're going to make mini equations sometimes. So this is a double starred. Make sure that you know this before we get to our next quiz next week, so we can keep that straight. So again, if it's numbers, 3, 3, x is 3, we pop that in front of the square root of 2. We're off and running. So, find the value of the variable. Write your answer as a simplified radical, if it is a radical. So here, for instance, it's just a comparison game. This is my hypotenuse. My hypotenuse is x times the square root of 2. That's 5 times the square root of 2. I know, Hardy, I don't need to write this down. This is the mindset, though, that we've got to be getting into, where it's like, okay, well, both sides have the square root of 2, so they just cancel. So x is 5. And, oh, well, these legs are the same. I better not mark it that way. You're going to think I'm saying 5x. X and y are going to be the same because it's a 45, 45, 90. Now, I'm going to mention one other thing here, too, while we're at it. Notice in this first one, I didn't even put the angle measures in here. All I put were congruency marks. So, for instance, we know this is 90 degrees, which means I have 90 left. And if these are the same, it's just 90 divided by 2. So it may not always be smack you right in the face with a number. We may have to dig and think a little bit when it comes to those. Ooh. Square. Okay. We can look at these separately. So I'm going to focus in on this one where I've got the 9 already. And if you want to, you could put 45s in for those other angles. Again, it's going to depend on how much information you need to feel comfortable. So if I start building this, my two legs have to be the same. Now I don't need that for an answer, but it could help me get where I need to be. And then my hypotenuse just means I'm taking my x and I'm putting the square root of 2 with it. And so again, knowing some things about shapes is going to help too. You're like, well, wait, if this is a square, all the sides have to be equal. So I can use trig to get that 9, because if I knew this was the hypotenuse, I could just lose the square root of 2, or I can use my knowledge of that. And that's not going to be any different within this particular section. Now, can it get a little fun? Yeah. Ooh. That's the hypotenuse. The hypotenuse is x squared root of 2. So to solve for x, we've got to divide by the square root of 2. Now, there's a fast way to get this, and there's a not as fast but still okay way to do this. So here's what I'll tell you. When you're dealing with radicals, as long as they have the same root, you can do regular division to this. 6 divided by 2 is 3, so this would be 2 square root of 3. Because I'll have some people, because we've done this before this year already, that'll sit there and go, well, wait a minute. If I'm trying to rationalize a denominator, didn't you tell us before that you just multiply the numerator and denominator by that same square root, which I did. Square root of 12, if I break it down, is 4 and 3, and I end up back at the same place. But dude, that, just a quick division, that's a whole lot easier than this. I mean, I can have this tool in my back pocket if I need it to build from earlier, but just reminding myself that as long as they have the same root, I can just divide or multiply or do whatever, a lot faster and a lot better. Oh boy, 45. Okay, these two legs, they're the same. I get one easy one, okay. Now, why? It's x times the square root of 2. Hardy, there's already a square root of 2 here. But this is the x value. That's just this. That's still part of my formula. And similar to what we did in number 3, so I can just multiply these? You can. The square root of 4 is 2, so 7 times 2 is 14, and I have my y value. Like, there's a lot of different little tricks that you can use. I know some people that just do division in one thing and multiplication here. I am more visual when it comes to this, so I like to actually write it out. But if you can find a pattern, by all means, do it. So that one, and I'm going to pause for a minute in case there's any of those I need to talk about again one more time before we hit 30, 60, 90, which is a little different in some ways, but not really. So any issues so far on finding sides or what the heck I'm doing on some stuff? Okay. So what changes when we get to 30, 60, 90? Well, we don't get the ease of both of our legs being the same anymore. And so the hypotenuse is still the long side, but when you're trying to figure out between short and long, it has to do with the degree measure of the angle opposite that. And here's what I mean. 30 is less than 60. So the side opposite of 30 is going to be shorter or less in value than the larger angle over here that goes to my long, okay? It's strictly based on the angle measure. The bigger the angle, the longer the side's gonna be. And so when we get to our base triangle here, the short side will always be x. The shortest side will always be represented by x. The long leg will be represented by x times the square root of 3, which is a little easier to remember because 30, 60, 90, they're all divisible by 3, so that kind of helps me remember the radical that goes with it. And my hypotenuse is going to be 2x. And so depending on the sides you get, and again, this is something we need to know, if I know the short leg, I just multiply it by the square root of 3 to get the long leg. And if I know the short leg, I just multiply it by 2 to get the hypotenuse. Now, am I always going to get that lucky? No. But once you know x, you know everything you need. So the reason I mention that is that now when we get down here, and we're like, okay, there's 60. This is the one I know. This is my long leg. So I think about it this way. I'm like, okay, so 4 square root of 3 has to equal my long leg, which is x times the square root of 3. Which is fortunate for me in this case because, again, if you divide by the square root of 3 to get x alone, the square root of 3's go bye-bye. I can get my 4 for my x really quickly. And y is just 2 times x. And I know some of you think it's silly to write 2 times, well, I know that it's 8. But will you later, if you look at this, to try and figure out where to get that from? I still say, at least during the notes, write those pieces down just to make sure that when you get there, you don't get yourself into a problem. Oh boy. This is my short leg. Should I wait? So this is x in parentheses here. So I'm like, if this is x, I'm just going to do it small like that because it's not that x. This is my x square root of 3. So here, this is 7 square root of 3, my short leg, times the square root of 3. Okay? X square root of 3. That's 7 times the square root of 9, which is 3. So I can get my x value. And again, once you have x, life is good because y is just 2 times x. And I can get to that value. So you've got multiple ways. I mean, I could have tried to go into this right away, but that would have been kind of messy. But it's doable. So nice. Did I do the exact same thing 2 times in a row? Well, that was silly. I wish I wouldn't have, but I did. Okay. That's my short leg again. That's my air quote x. Okay. So for my y, it's x times the square root of 3. So it's going to be really, basically, it's the same as what we just did. 12 times the square root of 9 is 12 times 3. But this time, y is not my hypotenuse, so don't assume that's always going to be the case, because it may not be. Uh-oh. Yeah.
On number 6, wouldn't x be the short side, so we would have to do 7 to the square root of 3 times 2?
Oh. Yes. Oh, dear. All right. Rewind. I did 2 times the long leg here. That's not right. That's the long leg. I should probably start labeling that too. You're right. So this needs to go away. We need to fix this. That is my x. So 2 times 7 square root of 3. Thank you. Yes, yes, yes. Let me make an adjustment on this so I don't go bonehead anymore. This is why I like the thing going back and forth. And you also save me because I'd have probably done the same thing again here. There's my x. So for x this time, we got 2 times 12 square root of 3. Yes, yes, yes. Absolutely. I appreciate that. I think this is the end. Yeah, we're not doing any applications till tomorrow. That's right. Okay, last one. Ooh. All right, so let's see here. I got my 5. We're going to do like we did up above. $30. This is my short leg. This is my x. Well, that's going to make my life a little bit easier. At least it looks like it. So my long leg would be 5 square root of 3. So if you're going, you're like, okay. And then that'd be 2x. So y is going to be 10. What's this x going to be?
5 square root of 3.
5 square root of 3, because it's a rectangle. How do I know that? I can see I've got parallel lines and a square root. So Otherwise, I could have worked backwards. But who wants to do all that? That gets to be a little crazy. So, okay. That's where we're at here, day one. We're going to kind of gently work our way back into things. So, how crazy do we need to get? We might need to get crazy. Let's see. All right, I'll do what I normally do here, except we'll do it this way. We're gonna trim some off of this. So we're gonna be playing today on pages 1 and 2. We don't need to go double puzzle here. Double puzzle's a little much. So take your pick on the 1 to 21 here. It'll get you plenty to mess with on things. And here is the answer to the puzzle, so you can see what's going on as you go here. This is a long puzzle. No smiley face in there. Why did the 30, 60, 90 triangle marry the 45, 45, 90? They were just so right for each other. I know, bad. Real bad, but that's okay.